Hello, and welcome to this session on using Ansible with Checkpoint APIs. I'm your host, Dwayne, and I appreciate being with you here today. In this episode, we will move common tasks to external task lists and continue making the playbooks more flexible. We will introduce a new playbook control directive and see what happens when we combine it with a loop. Along the way, we'll build a new version of our playbooks to see these concepts in action. So grab yourself your snack, your beverage, and let's get started. So far, our playbooks have been one big sequential list of tasks. This method works for a short time. You may have noticed a lot of repetition along the way, such as when using the debug module after each task. This really only works for very limited and very specific playbooks. We can improve this. Let's take another look at our last playbook. Similar to larger programming and development projects, we can make our playbooks more modular. We can move common groups of tasks, such as these, to their own dedicated external task lists. These external task lists are just that, a list of tasks. They're not playbooks themselves and they can't function on their own. Here is an example of such a task list. No, it's not very exciting, but notice a formatting difference compared to the main playbook. These task lists start on the far left margin, just like the inventory attributes. These external task lists are still written in YAML, just like the playbooks. The complete task is still written with all of their parameters as before. You can even apply loops to the tasks, just as before. To get us started, I'm keeping everything for these tasks intact, just as they were in the original playbook, loops and all. With these tasks moved to an external task list, how will we refer to them from the main playbook? Good question, glad you asked. Back in the main playbook, we have to make some adjustments. Introducing the include tasks playbook directive. This directive lets us do just what it says, include tasks from an external data file. The nice thing about using include tasks is that we can use this directive anywhere in the playbook flow we want, and we can use it as many times as we want, and even include the same external task list again. For the first demo, I'll edit the main playbook to replace these duplicate tasks with an include task directive and specify the external task list. Before we go too much further, let's run this playbook now and see what the output looks like, just so we can keep track of the execution flow. Everything looks just about the same as before, except now there is one extra line along the way. Here's the output for when Ansible is executing the include task directive. It also shows the name of the external task list being included. That's good to know. Everything else runs just as it did at the end of episode 7. In fact, there are no changed states either, because this is the exact same set of tasks. This makes the main playbook cleaner, but we can still do better. As a general rule, don't use loops inside the external task list. There is a better way to use loops. In the external task list, I'll keep all of the task parameters and variables as they were, but I'm removing the loop and loop control parameters. These control statements will be moved back to the main playbook where they will be applied to the include task directive. Yep, you can loop an include task directive. This creates some very interesting effects for us. The loop control parameter remains unchanged, along with the loop var, although I slightly trimmed the label. When using this technique, the loop item variable used inside the external task list has to be the one set by the loop var parameter from the parent task. When Ansible loads the external task list, these tasks are added to the playbook flow just as if they were written in the main playbook. Another not so obvious feature comes from Ansible's rules of templating for Jinja variables. You can't apply Jinja templating to the name of a task when trying to use a variable that is set within the same task, such as with the loop var parameter. That's why our task names haven't been very informative up to now. However, you can use templating for these variables within the external task list. This lets us use Jinja templating on the task names inside the external task list to add descriptive information such as the value of the loop item variable. When Ansible prints the name of the task, the output will be more informative. Another advantage of looping an external task list is that you can run a series of tasks that operate on the same item of a list to do multiple things. This should start lighting up some ideas in your head. In fact, we're going to work with some of those ideas now. Here's a new version of the external task list. First, let's do a debug statement to print the name of the current loop item variable. Next, call the host facts module to get the current state of that one object. Finally, another debug to print the contents of that object. Here's the new version of the main playbook. First, include the external task list and apply a loop for each host object item from the external variables file. Next is the host object module to make some changes, also operating in a loop from the host object variable list. Finally, the third task is just a copy-paste of the first one with the loop. Nothing is different. Do you see where we're headed with all this? At the end is the publish module, but you could use discard if you wanted or if needed. Save your work and let's run this playbook to see how it goes. See the effect? All of those external tasks were ran in series for every item in the list passed to the loop. The include task statement was repeated for each item. At the point Ansible calls the include task statement, it shows all items of the loop for which this statement is being applied. If you're new to this, that phrase might seem oddly redundant, but the answer lies in the clever wording I just said. All items for which this statement is being applied. Coming up soon, I'll show you what this means. For now, it just means all list items. If you're already wondering, can we call another external task list from within an external task list? You're absolutely correct. Yes, you can call another include task from here. The same variables get passed down to the next level, just like that movie Inception. You'll need to be mindful though, because just like Inception, you're descending to another level. Everything from above is still active and visible to the inner task, but not the other way around. Or if you prefer, this is the same as those nesting dolls you see in gift shops. You need to be mindful and careful with the planning of your variable names on the inner tasks. Ansible will let you override existing variable names in use, but that will cause some very unfortunate distortions that you might not want. Be careful if you plan on nesting. We'll see more use of include tasks from here on out, so you'll get lots of practice with it. We've been working a lot with the host objects, so now let's turn our attention to some other object types and work with the network objects, group objects, the TCP service objects, the UDP service objects, and the service group objects. Hopefully you still have the Checkpoint API reference guide and the Ansible module documentation bookmarked or pinned. You'll need these on hand to see the available parameters. From here on out, we'll be mixing in various object types, expanding the playbooks, and making things much more flexible. Okay, so let's get to it. As discussed back in episode 5, for almost all modules, the name parameter is required. Some objects need an extra parameter or two. Remember, the host object requires a name and an IPv4 or IPv6 address. Let's look at the other modules and find out what they need. First, we look at the network object model. It's very similar to the host object model. For network objects, both the IPv4 or IPv6 subnet and prefix length are required. If you're still using IPv4 subnet mask in dotted quad notation, do yourself a favor and switch to prefix length notation now to save yourself some trouble and extra work. Consistency is the name of this game. Besides, IPv6 only uses prefix lengths, so you gotta do it eventually. Next, we look at each of the service object models. Both service objects require the name and the port number. The service objects are a little more complicated since they have many other optional settings. You can include however many of these settings as you wish. I'm only including the most popular ones here, but check the module documentation and the management API reference for each one if you want to add more for your needs. These popular options are name, port, and the match for any boolean. In R80 and above, the match for any boolean now defaults to false, whereas in earlier version, this was default true. I strongly suggest you follow R80's guideline and default this to false. Next, we take a look at the group object type. Only the name parameter is required for an object group, but it also allows the members parameter. This is a simple list of host or network objects that should be in the group. Next, we look at the model for the service group object. Again, only the name parameter is required, and it also allows a members parameter. This is a simple list of TCP, UDP, or ICMP services. service groups follow the same rules as object groups. Yes, just as in Smart Console, for both group types, you can create a group of groups, in which case you modify one group to change the list of its nested group members. Or you can modify your inner group and change the list of what groups to which this group is a member. Modify the outer group or modify the inner group. Either way works. All of the object types allow a group's parameter. This includes each of the group objects themselves. This parameter is a list of groups to which the object is attached. Remember this simple rule. Groups can contain members. Objects can be attached to groups. Notice what's missing on both group object types, however. There is no parameter to arbitrarily add or remove objects from the groups while retaining all of the others. This is not possible with each group object module. If you want to make arbitrary changes to a group, you have to write that logic yourself. There are ways to do this, but we'll save that for a more advanced topic later. In the meantime, just know that this is a static list of group members. If you want to modify the group member list, you have to include all the members, not just the individual ones you want to add or remove. With each of the object models defined, here's how we will tie all these together. In our external variables file, let's add a named list of network objects. Let's also add some group objects. Feel free to add some more host objects if you like. We'll also add some service TCP and UDP objects. Each of the service objects are their own types with their own APIs and their own modules. We have to handle them differently. Same thing for service groups. However, now we have a decision to make. Where do we want to define the group object membership? Do you want to define it on each object item? Or do you want to assign the objects to the group when the group is created? There is no wrong answer, but the detail matters. Once again, whatever you choose, be consistent with it as much as possible. Yes, you can change your mind later if you feel like you made a choice that doesn't work well for you. For this example, I'm going to define the group membership on each object individually. Because of that choice, it determines how the task lists and the playbook get written. Next, let's create individual external task lists for adding each object type. Each one has its own module, so each one needs its own task. No matter how you try to do this, you have to write that task with the module. We'll make liberal use of the default filter and the omit magic variable just as before. Since we're also working with groups, and I chose to define the group membership on each object for the host object tasks, I'll revise that task list to include the group's parameter. I'm also including the color and comments parameter, which are common for all object types. Next, create an external task list for adding a group object and one for a service group. Yes, you can go ahead and add the members parameter here as well. Even though we aren't using it yet, there's nothing wrong for coding for the future and some flexibility. This will allow you to change your mind in the future about where you want to attach groups and their member objects. Yeah, that was a lot of new stuff there, but if you step back, you'll see that they're really almost identical. Other than the module names and a few select parameters, everything is identical and it follows the same outline. Here's our next main playbook to bring these ingredients together. The header section is the same as before, and the variable section will include the new version of our variables file. The main playbook is rather simple and rather boring, which is what we want. Nothing overly complex or confusing. First, I'll include group object task lists in a loop because we have a list of groups. The second task includes the host object task list, also in a loop. The third task includes the network object task list, also in a loop. The next two tasks are the service TCP and the service UDP tasks. Both of them are in a loop. Since we're now dealing with groups, remember the order of operations just as if you were doing this in Smart Console. What must come first? Host, network, and service objects, or the group objects? Well, again, that depends on where you decided to define the object's group membership. I chose to define it on the objects, so I need to create the group objects first, which will be empty. If you chose to go the other way, then you need to create your individual objects first, then the groups at the end to attach the objects. Okay, save this playbook and run it. The playbook loaded the external task list for each object and added or modified each one at a time. New things were added, existing things were modified. Easy and simple, just like we wanted. Anytime you need to do things, you only need to update the external variables file, and it will adapt to whatever variables file you give it. Using external task lists is one of the many magic powers of Ansible. Now you have new ways to design your playbooks and handle repetitive tasks gracefully. We covered more object types and made the playbooks more modular. Very nice! Be sure to hit that subscribe button below so you know when new content is available. And please leave a comment to let me and others know how this video helped you. Join me in the next episode and we'll do more with that pesky order of operations as we start deleting things.